Okay, thanks a lot, everyone, for tuning in. This will cover the latest updates in QC tools, which is versions 1.8 and 2.0. We anticipate doing some webinars later that might give more background material and kind of cover some of the functions in QC tools. But for today, we're just going to talk about the new stuff. So, and yeah, before getting going, this was definitely a huge team effort from all the people that you see listed on that slide. Really, I think it was Giuseppe Massetti and Chen Zhang that really did most of the heavy lifting on the coding. And thanks to Brian Calder and Sam Greenaway for like kind of the high-level guidance, and Barry Gallagher for his work in the software distribution, and Jack for the grid QA, and Janice and I have been doing most of the testing and training and so forth. So thanks, everybody. Okay. There we go. So here's an overview of what I'm going to be talking about. QC Tools version 1.8. This is what's intended to be used for single resolution grids, and the updates that we've had to this version are in Flyer Finder, the valve style checks, and the grid QA. So I'm going to be talking about that first, and then I'll get started on QC Tools 2.0, which is intended to be used just for variable resolution grids. So I'll talk about Flyer Finder there, and then I'll turn it over to Janice, who will finish up the talk there on 2.0, and then introduce Charlene as well, which is the tool that Eric Youngkin built for automated night processing. Here's a breakdown between QC Tools 1.8 and 2.0. So as I just said, 1.8 is to be used with single resolution. That's bags and Caesars. This is the version that you all are used to, that contains all those functions that you see there with the green checks or the updates, which, version 4 for Flyer Finder, version 3 of Holiday Finder, version 2 of the grid QA. For variable resolution, this can be used with a variable resolution. The Keras Caesar grid is what it supports. Later, in the future, we anticipate adding the bag VR when that is ready. And then also eventually we will add the other functions that are in QC Tools. We will add those slowly, eventually. Also, the intent is to eventually merge these so there's just one QC Tools version that will support either single resolution or variable resolution. That is the intent, but for now they are split. So I'm going to talk first about version 1.8. We're still maintaining all the single resolution functionality. We're still developing on it. This way, the field can choose what they want to use. If VR really takes off, they have QC Tools version 2.0 to support them. If folks are using single resolution grids, you always have version 1.8 to use. And the updates I'm going to talk about now are all in direct response to a lot of good input that I've gotten a lot from Fairweather and Rainier as well. The first one I'm going to talk about here is with regards to Flyer Finder. And so this will be a little bit of a deep dive here on Flyer Finder, specifically the adjacent cells algorithm. I think it's good if everyone knows how this one works. This is kind of the most prominent one for finding both deep and shoal spikes. Each of the algorithms are kind of tailored towards different kinds of flyers, and some that are suited for the edges. Some are on the isolated ones. But this is the easiest one that, in my mind, to understand what's being flagged and what's not. And everything I'll talk about here it works the same in variable resolution grids as well. The functionality of the algorithms is exactly the same. So all of this is applicable to both the single resolution and the variable resolution versions. So hopefully you can see that okay. That's an image there of, there's a deep flyer like around 17 meters, and it's surrounded by the seafloor, which is between 5 and 6 meters. So how the adjacent cells algorithm works is, for every single node on your grid, it finds as many neighbors as it can, up to a maximum of 8. There's 8 nodes all around each single node, up to a maximum of 8. There could be less than that if it's on an edge or something. So then what it does is it differences that 17 from each of its neighbors. So up to 8 maximum differences it finds. and the number of differences that are greater than the search height that you have entered in is just counted up. You just tally that, and then you compute that in a ratio, the number of significant differences to the number of neighbors overall. So if that ratio is greater than or equal to 0.8, the node is flagged. So I'll do a quick, the example, the image that you're looking at here. If your search height is 12 meters or more, this won't get flagged at all because there's no differences that are greater than 12 meters. But if it's 11 meters or less, then all 8 of the nodes around it are 11, that 11 meters or less. It's a significant difference against that search height. Okay, and it has 8 neighbors, and so that ratio is exactly 1.0. That node's going to get flagged. So here's this next example where it starts to get a little tricky because there's not just one anomalous node, but there's 2. There's 2 deep flyers that are like 12.3, 12.4 meters deep. And the other thing that's tricky about it is that there's some data gaps there. There's less than 8 neighbors. So in this case, if you have a search height of 4 meters or less, then the number of differences that are significant is tallied up, and that's 5. But you only have 6 neighbors there because of the data gaps. So the ratio there, 5 divided by 6 is 0.83, which is greater than that 0.8. So this node would still get flagged. So this next example I want to look at, this is something I've seen quite a bit. So there's 2 anomalous nodes that are 7.7 meters deep, and then the seafloor is around closer to 4 meters. Okay, so you have, with a search height of 3 meters or less, there's 3 significant differences, but there's only 4 neighbors. So that ratio comes out to 0.75, and so that node previously was not getting flagged. So with this first improvement to the flyer finder, in these kind of situations, in the case of 4 neighbors with a ratio of 0.75, that is going to get flagged. And the reason why is just because I saw this happening so dang much. It was Fairweather, you were sending me grids that, and you're asking, why isn't this stuff getting flagged? And a lot of the times it came down to this situation right here. So we went ahead and added it. It's something like, there's not, this kind of stuff really hasn't been done before, so we're adding stuff based on observations. What do we see? What flyers do we want? Are we sure that our flyers we want to be flagged? And we're making sure to account for those. Another thing we've added is because so often these flyers occur on grid edges or places where there's data gaps, we crawl a bit farther now to search for neighbors. Previously, the node that you see highlighted there, it would only have 4 neighbors, but now we crawl over those gaps, 2 nodes diagonally and 3 nodes in the cardinal directions. So previously that would only have 4 neighbors, now it has 6. And so with this improvement now, that has 5 significant differences, 6 total neighbors, that ratio is a 0.83. So that's going to get flagged no matter what. So again, this improvement is in all versions of Flyer Finder now, all the recent versions, most recent versions. Okay. Okay, now I'll talk about an improvement to the valve style checks. This came from good feedback from Rainier that to help let us know this was happening, and this is a good example of, it's a nice improvement for the version 1.8, but it also kind of highlights one of many ways where VR just inherently has great benefit, because what I'm going to talk about here is rendered totally irrelevant when you're talking about variable resolution. So, but for single resolution, what we have happening here is there's a rock right there that's getting flagged for a depth discrepancy and position issue, and what's happening is we're doing the scan during the valve style checks. It scans out to 4 millimeters at survey scale all around the rock, and it's searching for a grid node with that matching depth, right? And so sometimes this was happening. It scans around and it's finding some grid there, but not any grid that's directly underneath the rock. And so it's very unlikely it's going to find a depth match. So what we've done is we've asterisked. QC Tools is smart enough now. It asks the question, is there any grid data directly underneath the feature? And if there's not, it adds that asterisk right there. So you know that may not be a valid flag. And we've taken that a step further, and we've added inside the valve style checks, there's now a new checkbox right there called deconflict across grids. So what happens now is if you have several grids that are loaded, it's going to search each of the loaded grids for that feature if you have that checked. So here's the real situation back here. I don't know how well you can see that rock there, but there's a different grid of a different resolution that's under that feature. And so QC Tools is going to search each grid, and if it finds a different, data from a different grid under the feature, it'll just remove the flag altogether, and you'll never see the flag. So that's even better. Okay, another improvement from the grid QA, also prompted by good feedback from Rainier. This has always been a nice tool. It has our spec baked right into it as far as our tolerance for uncertainty, and that's our TVU QC equation, the ratio of computed uncertainty to our allowable. There's those A and B coefficients that are dependent on whether or not the depth is 100 meters or greater. So those just get adjusted automatically by the water depth. So the output is it's a more accurate result, per our specification. So that was a nice addition. Okay. Oh yeah, there you go. Automatic adjustments to the A and B coefficients. All right, moving over to QC Tools version 2. Again, I'll talk about Flyer Finder first, but I mean, everything I already said about how that algorithm works already applies to this variable resolution implementation. So what you're looking at here is this is a variable resolution grid with the resolution map turned on and the grid being drawn. So you can see this is at the edge of a tile where there's an entirely different resolution just north of this one. And so previously in Flyer Finder, what you had the option to do was you click the button called Estimate Heights. That would estimate a single search height for the entire grid. That button's gone now. And instead, an auto-estimated search height is done automatically for each tile of the variable resolution grid. So it's an adaptive search height for each tile of the grid. And so in this case, what you see happening is this is the exact same scenario I was just talking about, where I don't know how well you can see it, but there's two nodes that are 46 meters depth, whereas the seafloor around it is 25 meters. And it's the same situation where it's 3 out of the 4 nodes have that significant difference. And so this is going to be sure to get flagged. Okay, as with the previous versions of Flyer Finder, there's still a limitation when used in the real steep and deep bathymetry. Flyer Finder is something that's always worked best and on high resolution grids in the East Coast or Gulf of Mexico. It can at times give excessive false positives that may actually prohibit its use. So this is something that we have a lot of good ideas on how to mitigate. We're looking at exploring like a specific mode, specific settings for steep and deep. It just needs more testing. We need to look at more variable resolution grids in that bathymetry, but it is an active thing that it's just ripe for innovation. We're trying to find out what the best answer is. So that's going on. In the meantime, what you can do is, you can always just fall back to your traditional methods of grid review. All those things that should be being used all along, but just rely solely on those. If you're getting, I know we had talked about this offline, but if a lot of flyers in certain areas, it may be worth it to just go ahead and brute force data clean, which I know is not an option that a lot of people like to do, but if you're finding that you need to have these constant cycles of recomputing your grid, that's not a great scenario either. For use of Flyer Finder, what you can do, until we have better development here, in these real steep and deep areas, you can force a very fine search height and look at the flags in the shallowest parts of your grid and ignore the millions of false positives you might get in the deeper water. And then for the deeper waters, have a very coarse search height to just find the worst of the worst anomalies out there. So that's one way to deal with it in the meantime. So, okay, that was my last slide. I'm going to switch it over here to Janice, and then after that we'll bring up the software and look at some do some demos. So, all right, Janice, it's coming your way.
Great, thanks, Matt. All right, is everyone able to see my screen?
I can see it, Janice.
Okay, fantastic. So I'll talk about the updates to Holiday Finder and Grid QA for variable resolution grids. This is for QC Tools 2.0. So Holiday Finder v4, the main update for that is that now it is evaluating Keras variable resolution surfaces based on the Holiday definition for both object detection and complete coverage surveys that's defined in the HTD. So HTD 27.2 that you have all seen for the acceptance of Keras variable resolution grids. I suspect this will get rolled into specs for next year. But for this field season, this is where that the requirements are defined. So essentially, the Holiday analysis is functionally the same, right? What I have here is it's just taken from the HTD, and this is for object detection, how holidays are defined. So it is still the example that you see here. The water depth is 20 meters or less, and you could see still the holidays defined as, you know, any gap that is basically 3 times the course's allowable resolution or greater. So A is a holiday, B is a holiday, C is not. So, you know, holiday is still functionally the same, but the math is different for a variable resolution grid. And I'll just show you a little bit about how we got holiday analysis to work behind the scenes for Holiday Finder for VR surfaces. So our solution here was to resample the Keras VR surface to a single resolution grid. And you'll see in the next slide and in the demo, there's some options for this. But the default is to resample it to the finest resolution in that VR surface. So say you've created a VR surface with a minimum resolution of 1 meter, and of course this resolution of 16, it's going to resample that entire VR surface to a fixed 1 meter grid. So what you see here in this image, in the black, you could see the VR surface. You could see both the blue is the tile outline. You could see the actual cells themselves and the grid nodes in black. So you see here tile boundary with areas of different resolution, and superimposed in this is a much finer single resolution grid. And you could see anywhere that you have data, it's just being resampled to that. And we're doing the holiday analysis on that fixed grid then. So you see here this holiday size, right? If you could see where I have my mouse, you actually have coverage within that entire grid cell. So that's all covered out. And then we're just measuring basically across across all the space that's, you know, a holiday in that single resolution grid. So it's computationally probably a little more cumbersome than the current tool. So there's a couple of user options there, and we'll explore this more in the demo. You can resample to 100%, which would be, say, for a minimum resolution of 1, it would resample it to a 1 meter grid, all the way down to 50%. So that would resample it to 50 centimeter. So there's kind of some pros and cons here. If you keep the default of 100%, it runs pretty fast. There is the potential for false negatives, or especially for something that maybe is like right on the edge of being a holiday. I have to say personally, I've tested a number of data sets and I haven't actually seen, I haven't experienced any false negatives, but you know, it's a good concern that the developers had. Bumping that down to 50% will reduce the probability of the false negatives, but it also increases the time required to actually execute. So I would say I'd recommend going with the default, especially if time is a concern, but if you want to be overly cautious, you try bumping that down to 75% or even 50%. So once you actually run the algorithm, you'll get an output as I think a 000 file, a shape file, and maybe one other format that you would then bring into HIPS and SIPS or BDB. And just an overview of what you'll see. So holidays are flagged with either a 1 or a 2. And what that is it's a status flag. So 1 is everything that the algorithm is absolutely certain this is a holiday. It'll flag it with a 2 if it says, hey, you know, this might be a holiday, but I'm not sure. So, you know, why is it doing this? Well, in order to handle memory during processing, it's actually chunking that single resolution. It's chunking the grid into memory. So it's essentially reading in like very large strips of that data. So here's an example. You see, this is, I don't have a scale here, but this is a really large holiday. It's like an island. And when it's reading it through, it's actually, you know, as it's reading in one strip, but it doesn't actually see the other side of it. So it's going to flag it once, it might flag it again, and it put in a 2 there too. So I guess all of that's kind of a long-winded way of saying, you know, where you have holidays, Holiday Finder v4 is really, really good based on what we've seen in testing at detecting those holidays. You just might see really large holidays flagged more than once, or with the 2, but you know, I say, you know, better safe than sorry there, and you could always deconflict that later on in HIPS. All right, Grid QA version 3. So this was updated also based on the updated HTD 27.2 as well as the 27 specs and deliverables. So whereas before, previously for single resolution grids, right, Grid QA was evaluating for density and uncertainty for VR surfaces, we now have a core assist allowable grid resolution requirement. So that's defined in the HTD, and that is also being checked during Grid QA. So I'll show you an example of that. So all of these, the 2 graphs that you see outlined in red are new, and they define whether the grid met the coverage requirements, the course's allowable requirements, that is, which is different for both complete coverage and object detection. So it's going to produce both of those, you know, that we don't have a setting right now to specify whether it's supposed to be complete or object detection. So it's just evaluating for both. So again, most of these graphs should be familiar. You see here for the specific grid that I ran, the first one that you see up here is for, what is that for? Oh, that should have been for density. Okay, I apologize, but yeah, you'll see a density graph in there, an uncertainty graph, as well as the 2, you know, whether it meets the resolution requirements. And then there's some additional graphs that have always been in there. For example, the depth distribution, just to help, you know, kind of deconflict anything that you're seeing. So that's Grid QA. And then we'll end just with a plug for Charlene. So this is Charlene version 1.0. Eric Youngkin from HSDB has developed an automated night processing script. If any of you haven't yet seen it, I highly recommend you open up Pydro and take a look. I think that this is tremendously valuable to us, and really I think along with going with VR surfaces, it really has the ability to improve, streamline our operations for this season. So I think if Eric hasn't already, he will soon be including QC tools within Charlene. So as part of the processing, it should actually, you know, it'll create those surfaces and also evaluate them with QC tools. So just a plug for that. And I think he was actually out on Fairweather, so you guys should have at this point much more experience than I do at this point in time with it. So I think that is the end of our slideshow. So I will pass the baton back to Matt, and he can start the demo. Send it back to Matt.
All right, thank you, Janice. Are you seeing my screen? Are you seeing that, Janice, or someone?
Yep. Yeah, Matt, I can see it.
Okay, thanks. Okay. Here, well, let me first, before I get into BDB here, let me pull up. All right, so if you've installed the latest installer for Pydro Explorer, you have QC Tools version 1.8 and QC Tools 2. And there's, you know, it's nice and highlighted here. You know, this version of QC Tools only for single res, For VR, use QC Tools, and here it is. Those are both available also under Branch Tools, and so you all know how to do it. You just click the button and run it. Couldn't be any easier there. And okay, here in this is QC Tools 2.0, and again, we have currently Flyer Finder, the Holiday Finder, and the Grid QA that are available with plans to add the other functions. In the future, you can specify your output however you like it. You get the S57 no matter what in the PDF reports for those functions that have one. So I've already loaded a VR grid here, and so here in Flyer Finder version 5, you used to have that estimate heights button. Again, that's gone now. It'll do that automatically. It's the same routine to do so using the depth median, the assessment of depth variability, and the roughness using the standard deviation of the Gaussian curvature, although that is something we want to reassess for variable resolution and optimize. So for now, once you have your grid loaded, I mean, for the default, if it couldn't be any easier, you just load the grid and just hit the button, right? If you do want to change anything, unlock it as you've done before. You can still force a flyer height. We've kept that. That can still be quite convenient. If you're unhappy with the output from the default settings, you can force whatever flyer height you want, or you can enable or disable these algorithms as you like. So yeah, then you just hit go, and then your output is right now I have loaded the S57 file. They're sounding objects, and they're overlaying my VR grid right now. So I'll show you kind of how I look at this with respect to the searching for flyers and some different visualization things. So I pretty much always have the resolution map on. That's the last layer that you see here in the VR grid, because that lets you know if you're looking at the best resolution or not that can be supported. So I mean, obviously right now I'm looking at an overview of the grid, and there's obviously more than 4 tiles, which is what the current view suggests. So and also the fact that it's colored blue, that lets you know it's not yet the finest resolution. So I also loaded in a layer from Flyer Finder, which has a lot of potential flyers here. So I'm going to zoom in on one of these. There's a 4. This is from the edge slivers, so it's something that has a depth difference that's kind of right off the edge of a grid. I'm going to go in here. So I've zoomed in a bit. You can see the edge of a tile, but notice that it's still blue. That means you're still not looking at the best resolution. So I'm going to zoom in some more, and it's still blue. So I'm going to keep going in, and I want to see I want to know if this is a flyer or not. I'm evaluating this. And so as we get down into it, okay, now it just turned orange. So now I know that I'm looking at the best resolution. So that's definitely what I wanted. But now there's something curious here, because it's like I see something's flagged, but there's not even any grid underneath it. So what you need to do once you're looking at the grid in this, at this level, at this very fine scale, you go. It's the properties in your depth layer, and you go in here and turn on the points. And so down here underneath the points in the display mode, so now now the points are colored. I used an override color. You could also color them by a color map too, but you might have trouble seeing them on the projector right now. I also like to use some transparency in the depth layer to help see these points a little better. But the main takeaway here is that there are some points, some depth nodes that are indeed out there that you wouldn't have known because they're just the way the visualization is. It's important to know that can't happen, and you need to turn on the points and be able to see those. So this was something flagged by Edge Flyers. If I want to know what's going on there, the best thing to do is just to select the depth layer and just grab the nodes, and that tells you the story. Look at these depths, and you see, these 2 nodes that are just off of the grid are showing a depth of 15.5 meters, and the rest of them are all about 4 meters. So that's a deep flyer you'd want to cut out there. So that's one thing one case I wanted to show. I'm going to zoom back out now, before zooming out, you can leave the points on. I usually like to turn them off just to try to make it draw faster. Keep the resolution map on, and I'm going to go back out here. So that's here's my full overview again. Now I'm going to go into another case here. Here's a 2, something flagged by Gaussian curvature. Usually the way Flyer Finder works, well, actually I should say always, it does the Gaussian curvature first, and that algorithm is good at finding the worst of the worst flyers, and then the adjacent cells runs and gets all the rest. A lot of times something that's flagged, if you have Gaussian curvature disabled, then the adjacent nodes will usually pick it up anyway. So anyways, I'm zooming in, and another thing that's helpful to do in your resolution map, I don't have it on right now, but I'm going to turn it on, is to show the grid in your resolution map. And so this is nice here. You can see, I'm not at the finest resolution yet, but it's drawing those cells. And so as you get into your finest resolution, you get an idea of, immediately get an idea of what the resolution disparity between, from tile to tile. So now I notice that the background has turned orange, which is nice, because I know I'm at the best resolution. You see there's an intersection of 4 tiles that all have different resolutions. And so that means that they also have different flyer search heights that were computed automatically based on all, grid roughness, variability, and the mean depth. So I want to keep zooming in here, and I want to check out this flyer, or this potential one that was flagged. And this is just kind of interesting because it's right close to the border of another tile that's clearly at a different resolution. So once again, I'm going to turn on my points. There they are. And so let's see what's going on here. It's another deep flyer. I'm going to grab these, look at the depths, and there you go. There's a 16 meter right alongside depths that are between 7 and 8 meters or so. So that's it. Yeah, really, all the algorithms work exactly the same. Just the big takeaway, I think the most important things are just those certain visualization techniques that I think are really important when you're looking at VR grids that likely Janice has already talked about a lot, in the VR training and stuff. But I just want to show that again with regards to looking at flyers. So, all right. I'll turn it back over to you, Janice, for some look at the holidays.
Okay, great. Thanks, Matt. Yeah, I really do want to drive home to everybody the importance of the visualization techniques. I think, right, that these tools that we've developed, the QC tools, really help point us, drive your eye what you should look at in your surface, but along with that, you need to be visualizing it properly in HIPS, and there's a couple of different techniques for that, and I'll show you that with Holiday Finder too. Matt, can you see my screen okay with QC tools up?
Yes, I can see it fine.
Okay, fantastic. So I've loaded in a grid here, and I'll go through some of the dialogue. So this is for Holiday Finder. You click on this tab, and it's pretty simple dialogue. There's really one main toggle, and that's to enable the user to toggle between 3 modes. So full coverage will obviously detect for full coverage holidays, and for object detection holidays, you just move it to that. So all holes is going to find literally every single hole in your surface, even if it is not a holiday. It will just find any grid nodes that are unpopulated. So I don't quite recommend that. I'm sure there's some use for it. But just be mindful of making sure that you have selected the correct toggle for the coverage requirements for your survey. If you forget which one that you've done, the file name will actually reflect all of the parameters that you've chosen here, which is actually very useful. So it retains not just the coverage settings, but all of these other parameters here. So these are user optional settings. Up here, as I mentioned earlier, you could, actually no, this is the upper holiday area limit. So I think, Matt, this was also with a previous version, but this is basically if you don't want Holiday Finder to flag the really, really big holidays, the quote unquote, obvious holidays, then you can put a limit here. My preference, my strong personal preference is to make that unlimited. And if there is a holiday in your grid, even if it's an obvious one, I would rather have it flagged than not flagged. That being said, I think there is actually in the code a limit. I think, maybe some number like 1 million grid nodes or higher still won't go detected. So it's not literally unlimited, but essentially it is. And in terms of the resolution, so this is where it sets the resample rate for resampling the VR grid to a single resolution grid. So 100% is 100% of the minimum resolution among the tiles. You could set it also to 66% or 50%. So if you click on that button, you'll get this warning dialog, making sure you really want to change the settings, and then you can go ahead and do that. And again, if you've forgotten which settings that you ran it with, which parameters, those will be reflected in the file name. And then you would just click on Find Holiday V4 and it'll run. Just to save time, I won't actually run that right now, but I will bring up the results in Keras. So I have here a sample grid that I've been using for testing. This is a VR surface from a fair weather survey, actually. And I took just a couple sample lines, ran a grid, and ran it through Holiday Finder. So let me zoom into a few areas in this grid. So here, oops. I have my measure tool on. Here we go. Zoom in on this one. And you know what, I should take a cue from Matt and actually put on the resolution map. I like to do that too, just to show me when I've actually, again, it's blue and the surface is still generalized, and it turns orange when you've reached the furthest extent. So here it's orange. You can see, now that I've zoomed all the way in, go to the depth layer, and turn on not just the surface, also turn on the points. And then, I don't know if Matt showed where you get to this, but under the resolution map is where you show that grid. It's not under the depth layer, but it's under the resolution map. So you could see here the actual grid cells within the tile. So just one, to underscore what Matt said, is the different ways of visualizing a VR surface, which is to say the point, both the surface itself, the wireframe, and the points are actually different. And I can explain that a little bit more. So the points obviously are, showing you where you have actually populated grid nodes. If you don't have a point, it's not a populated grid node. And what both the mesh and the wireframe are is it's the tin that it's showing. And Keras VR, the rules for drawing that tin, I think it will only actually connect to connect a point if it has two contiguous neighbors. So you could see here this area where I'm kind of circling with my mouse, right? But these points don't actually show up in either the wireframe or the surface view, because they have either, say 0 or just one neighbor. But as soon as it has 3 neighbors, that is when I believe that it's 3. No, it's 2, sorry. I believe it's 2. But if it has 2 contiguous cells, then it will draw the mesh between it. But when it just has 1 contiguous populated cell, it's not going to. So that's really something I think needs to be underscored, right? If you are not going to show the points, turn off the points, then it appears that that gap is actually much larger than it is. When you turn those points on, then you'll see that quote unquote gap, or that gap is really just, much smaller there. So, so you could see here, Holiday Finder flagged this with the 1. So what it's actually doing, let's see, the depth here is 4.2 meters. This is a complete coverage survey. So I think the requirement is that the gap must be, in order to be a holiday, has to be 3 meters by 3 meters, right? If the coarsest allowable grid resolution is 1 meter. So let's see what the resolution is here. I think the resolution is, okay, so it's a 0.2 meter grid here. in any case. So let's measure the distance and the angle. I mean, the whole point is that you shouldn't have to do this, but if you want to verify, so it's about, you know, the gap is about 3.5 by 3.5. So this is actually a holiday. And just a word on the analysis that we did. So I took a number of data sets and I very painstakingly did manual holiday analysis on that and then compared the output against Holiday Finder and found that it performed very well, even with a setting of 100%. And again, you know, I strongly suspect if there is anything that would be missed at 100%, it might be something that's very, very borderline holiday. So it's certainly, I don't think it'll miss anything that's obvious. And then I'm gonna bear with me for one moment. I'll zoom out and I'll show you just another example of where it's gonna flag more than once. So I'll turn the points off. And just like Matt said, I found that the redraw, I know several of you have noted that the redraw can be a little bit sluggish. I find that sometimes, you know, not having it display as much can help. So turning off some of the layers. There we go. Let's see. This is interesting. I might not actually have it flagged more than once. Yeah, so it has just flagged this this holiday one. So Giuseppe must have improved the algorithm since the last time I ran it. But in the first iteration of the algorithm, it was actually taking this very large holiday. Let's measure this here. Yeah, it's like 0.5 kilometer. And because it's, you know, reading it in chunk by chunk by chunk, it's actually, you know, flagging it multiple times. So, but you can see that's not the case here. So that's a good thing. And then there's a couple of smaller holidays in here that it flagged. So I think that's about it for Holiday Finder. And we went over the different visualization stuff. So let me bring it back to Grid QA. So for Grid QA, again, you'd add your grid file, set your output folder, and then there's no settings. You would just run the Grid QA. Actually, Matt, could you jump in and explain that forced TVU QC calculation?
Sure. Sometimes, or pretty often actually, a layer has already been generated in the field or at some point previously that is that TVU QC layer. And so if that's already generated in the grid, if you don't click that, then I believe QC tools may just use that layer. If you check that box, then it will recompute a TVU QC layer regardless of whether or not you have one already made.
Okay, great. Thanks, Matt. So that explains that, and you would just click that button and let it run, no other parameters. And then I'll bring up, you'll get a folder, an output folder with a bunch of graphs in them. Most of these should be very familiar to you. Can everyone see my screen okay? Oh, it's rather a small image here. Matt, can you see that okay?
Yeah, I can see it good enough.
Yeah, I'm trying to think of, can I zoom in on it? There, maybe that's a little bit better. There we go.
Yeah, that's better.
Yeah, so that's much better. So you could see here, object detection coverage. So this is showing the sounding densities, the soundings per node. And you could see here that 99% pass in this case. Let's see. Open up some of the other graphs. The depth distribution should be pretty familiar. to you. The other ones we look at are the uncertainty standards. So you could see here over 99% pass, so fine there. You're only concerned with anything that goes into the red. And this is really the graphs that are the new addition for variable resolution surfaces. So evaluating that the grid resolution is finer than the coarsest allowable. So you see here in this case it's a complete coverage survey, and it verifies that greater than 99% pass the standards. So you're within spec on the resolution requirements for a VR surface. So I think this is most important, right? When you create a VR surface, you have a few options. You can create a range of surface where you tell it what resolution you want to grid it at. You're essentially telling it to, grid at the coarsest allowable resolution most of the time. So you would expect, right, that all of the grid nodes are going to pass. With the density-based estimator like Calder-Rice, you are giving it criteria and then telling it to grid at the highest supported resolution based on the data density. And so that's where the algorithm is determining what the resolution is. So I think that's where these graphs are going to be really important, right? Just to prove, to make sure that you're actually meeting those requirements. And, during Keras VR acceptance testing, I had an early version of this algorithm, and I made sure, all of those VR parameters should meet all of our spec. It's one of the most important factors. So again, if you use the VR parameters that are included within the HTD, you should have no problem meeting the spec. But now you have an easy way to verify that with QC Tools 2.0. So I think that's it for the demo and the presentation. Matt, should we open it up to questions? Or did you have anything else to cover?
Nope, I'm done. Yeah, just say, thanks to the field. Keep the useful feedback coming, because that's what, drives the further development. And yeah, if there's any questions or anything that we want to talk about, now's the fine time to do so. Also, I'm looking at chat if anyone has any, if anyone wants to type something in. Oh yeah, I realized I should probably unmute everyone.
Oh, is everyone muted?
I think so. Let me check here.
Okay. Yeah, I was surprised that there are no questions, especially